Good morning once again. Today we are going to talk about the network layer, or sometimes we used to call it as your internet layer protocol. So that in the previous class we might have discussed about the call forwarding, or we just find the concepts of forwarding and the routing in the network layer. So as we know that there are the end devices. I'll just introduce those. Oh, yeah, yeah. So here, I think the screen is visible. Yeah. So here you can see in the to form any kind of network. So what we required and what we need, that you can just check it out here. There are the end devices we used to call, and these end devices. Just a second. Okay. So if you go through the end devices, here you can see the different kinds of end devices. PC is there, laptop, server, your the mail servers or network controllers, printers, different kind of the devices that you can identify here. So how these devices are identified in the network? So that you can see the PCs. Uh, yeah. So here you can see the PCs, laptops, or your server, your the mail servers, or we call the Meraki servers, the network controller, your printer, your iPhone. Okay, so these are all known as your end devices. So how these end devices are identified in the network means, as we discussed in previous cases, that you can see using your IP addresses, right? You can find the IP addresses. These IP addresses are generally, represented in various ways. So that we discuss one by one. But how these devices are identified in the network means using their end devices itself, right? Let me just stop this and share the PPT for you. Yeah. So in today's lecture, we talk about these end devices and their IP addresses. What is the structure of your IP address? Okay. So in this, the objective of this particular network layer is to explain the features of your an IP address, where we cover the different topics of your IP addresses. That is, what is the purpose of your IPv4, and the binary conversion of your IPv4, and then the IPv4 for address structure, and the classful IPv4 addressing, then public and private IP addresses, and unicast, broadcast, and multicast addresses. So these topics are very important for any network engineers and to understand and how these addresses are allocated to the devices uh, in the network, right? So, first of all, let us go with the first part. What is the purpose of your IP address, and how do we, use these IP addresses that we discuss, right? So, any host that needs an IPv4 address to participate on the internet, and almost all local area networks today, right? So, you may have doubt that IPv4 stands for what? Okay, IP stands for Internet Protocol, where 4 stands for, V stands for the version, and 4 stands for your 4 bytes are used for your IP address. 4 bytes means how many bits? 4 bytes means 32 bits are used. Correct? So these IP addresses are used for any host to participate in the internet or your local area networks. So the IPv4 address is a logical network address that identifies a particular host, not physical address. Physical address means you find the MAC addresses. Okay? And IPv4 is logical address. Why we used to call it as logical address means whatever the IP address assigned to a particular end device at a particular time will not be forever for that particular device. After the some instance of time, the same IP address may be given to other end device also in that local area network. So logically, the IP addresses are assigned, not the physical one. That's the difference, right? So these IPv4 addresses, as said, they are the logical network address that identifies a particular host in the network, and it must be properly configured and unique with the local area network for local communication purpose. Similarly, it must also be properly configured and unique in the world for remote communications. So this is how a host is able to communicate with other device on the network or on the internet. So an IPv4 address is assigned to the network interface connection for a host. So this connection is usually a network interface card. We used to call it as your NIC, network interface card, right? And that is installed in the end devices. The examples of end user devices with the network interface that includes your workstation, servers, network printers, as said, as shown just now, and the IP phones. So some servers can have more than one network interface card. Remember this point. Some servers they'll have more than one network interface card, and each of these has its own IPv4 addresses. So the router interface that provides connections to an IP network will also have an IPv4 address. So every packet sent across the internet has a source and destination IPv4 addresses. Source and the destination IPv4 addresses. You can see in this diagram. So there are different servers are there here, right? One is cisco.com server is there, another one is business A server is there, business B server is there. So every server is having their own IP addresses. So the cisco.com server is having 64.100.0.1. Our business A is having 192.0.0.1. Business B is having 209.165.200.1. So every device or every host, or we call the every packet sent across the internet, has a source and destination IP addresses. Okay, and the information the IP address information is required by the networking devices to ensure the information gets to the destination and any replies are returned to the source, right? So here I just want to play a particular video so that you can have a bit glance over here. See, the man is sitting at one corner and want to send some packets to your cisco.com server, and that packet goes via your the yeah, that packet goes from this user end user via our internet to your cisco.com. You just observe how it is going on. So the destination address is 64.100.0.1 for this message, which is going via your internet and reaching to your, the server. Here you can see on server side, the transport layer for this particular message will generate the acknowledgement, and that acknowledgement is coming back via the internet to the source itself. Clear? So once whatever the request is sent, based on that, the response from this cisco.com is coming. Here you can see once again, the request is going to cisco.com from the end user that he wants to open the cisco.com, suppose. And that HTTP request goes to server, and from there, the web page is retrieved, and that web page comes to your source, and that will be displayed as your cisco.com. You can observe here. Is that clear? So to identify any devices, they require the IP addresses. They require the IP addresses. That is the meaning. Yeah. So now you can see a kind of activity that I request you all to install the packet tracer tool on your devices during this particular network layer IP address discussions. So that will be helpful to understand one by one. Okay. So now see IPv4 addressing. Now how this addressing will take place, that we discuss. IPv4 addressing part. Okay. So an IPv4 address is simply a series of your 32-bit binary number that consists of your zeros and ones. So there are over 4 billion possible IPv4 addresses using a 32-bit addressing scheme. So it is very difficult for humans to read a binary IPv4 address or addresses. So for this reason, the 32 bits are grouped into 4 8-bit bytes. 32 bits are grouped into 4 8-bit bytes. They are called as your octates. So an IPv4 address in this format is hard for humans to read, write, and remember. So to make the IPv4 address easier to understand, each octet is presented as its decimal value and separated by a decimal point or period. So this is referred to as a dotted decimal notation. Dotted decimal notation. So when a host is configured with an IPv4 address, it is entered as a dotted decimal number, such as on the screen you can see on right side. Here you can find the Internet Protocol version 4 for your TCP IP version 4 property, where the IP address is assigned in the form of your dotted decimal. 192 is one decimal, 168 is one decimal, 1 is one decimal, and 5 is another decimal. So what is means total size of this IP address is your 32 bit. Okay? So these 32 bits are divided into 8 bytes. So these 8 bytes we used to call as your octates. So see, if you divide this 32 by 8, how many fields you will find? 4, right? So there are 4 fields are there: 192, 168, 1, and 5. These are 4 fields. They are separated with the dots. like dots are represented here, right? Okay, so um, so when a host is configured with this IPv4 addresses, it is entered as a dotted decimal number, like you can observe here 192.168.1.5, right? And this is the 32-bit binary equivalent is 110000001010 and so on. So is it possible for any human being to remember this single IP address in terms of binary? That's why it is these 32 bits are divided into 8 bits byte, and those 8-bit bytes are converted into a decimal value, and they are separated with the dots. So if you mistype just one bit in this 32 bits, 110000, the complete address will be changed. When address changed, the host will be changed. So to identify any host is very difficult, right? So then let us see how the binary to decimal conversion takes place. As we know, the IP address is in the form of your 32 bits. So how these bits, binary values, converted into your decimal conversion. So for that, let me just play a video for you, and that will be helpful for you. Let us see, and then we'll come back to the discussion part. Uh, just a second. Okay, I think it is visible, right?
In this video, we're going to take a look at the binary number system. We're also going to see how to convert from binary to decimal. First, a brief look at the fundamentals of number systems. In all number systems, the first digit begins with 0. So whatever base we're working in, that tells us how many digits or how many numbers are in that number system. For example, decimal, base 10 number system has 10 digits. Starting at 0 through 9, that's our 10 digits. Binary is base 2. Base 2 has 2 digits. Starting at 0, 0 and 1 are our 2 digits. So the first column in our number system is always the column of ones. Whatever base we're working in, the next column is that times the previous column. Let's take a look. In base 10, the column of ones, our rightmost column. Base 10, the next column would be 10 times 1, or 10. The next column would be 10 times that, 10 times 10, or 100. The next column, 10 times 100, 1,000, and so on. In base 2, we also start with the column of ones. Base 2, the next column would be 2 times the previous column, or 2. The next column after that would be 2 times 2, 4. The next column, 2 times 4, 8, and so on. So in base 10, we said the first column is the column of ones. Next column is 10 times that, 10, then 10 times that, 100, etc. What digits can go in each of those columns? Well, any digits in our number system, 0 through 9. So whatever I put in the ones column is how many ones I have. Like 1 is 1, 1. 2 would be 2 ones. 3 would be 3 ones. 9 would be 9 ones. That last digit in our number system. So 10 would be 1 in the tens column and 0 in the ones column. That gives us our 10. So The 1 in the tens column means the number of tens, as opposed to the 1 in the ones column, which is the number of ones. 99 would be 9 tens and 9 ones. 100 would be 1 100s, 0 tens, and 0 ones. Now this may seem really basic, but understanding base 10, the decimal number system, you can understand any number system. Let's take a look at the binary number system. The binary system, the first column is our column of ones. The next column, because base 2 is 2 times this column, so that would be 2. The next column, base 2, 2 times 2 is 4. The next column would be 8, and we'd keep going, but we're going to leave it at this. Okay, so what can go in each one of these columns? Well, we're using base 2 binary. So we only have a choice of 2 digits, a 0 or a 1. Let's take a look. So a 0 in binary, 0 ones, that's equivalent to a 0 in decimal. A 1 in the ones place is equivalent to 1 in decimal, a 1. Now remember, in binary, we can only use a 0 or 1. So 1, 0, what this means is how many 2's do I have? I have 1, 2, and 0 ones. That equates to 2. 1, 1 in binary is 1, 2, plus 1, 1. 2 plus 1 is 3. 1, 0, 0 in binary is 1, 4s, 0, 2s, 0, 1s. So we have 4. Wherever we have a 1, we just add up that column. If we have a 0, we don't add that column. It's that simple. So as we can see, 5 would just be 1, 0, 1. 6 would be 1, 1, 0, 1, 4, 1, 2, 0 ones. 7, 8 would be 1 in the 8s and 0 in the 4s, 2s, and 1s. 9, 10. 10 would be 1, 8 plus 1, 2. 8 plus 2 is 10. 11, 12, 13. So 13 is 1, 8 plus 1, 4 is 12. Plus 1 is 13. 14, 15. 15 is 1, 8 plus 1, 4 plus 1, 2 plus 1, 1. 8 plus 4 plus 2 plus 1 is 15. So what would 16 be? You're right. 16 would be, we'd have another column over here of 16s. 2 times 8 is 16, so we'd have another column over here, and it would be 1 in the 16s column, followed by 0, 0, 0, 0. So let's look at how to convert from binary to decimal. It's very simple. So given this binary number, what would be the decimal equivalent? You're right. All we have to do is add up. Wherever we have a 1, add up that column. We have 1, 2, 0 ones. That gives us 2. What would this be? You're right. 1, 8 plus 1, 2, that's 10. How about this? We have 1 in the 16s, 1 in the 1s. What's that give us? You're right. 16 plus 1, 17. How about this? Notice that each column is 2 times the previous column. So 164 plus 1, 4. See, that's 68. Plus 1 in the 2s, that's 70. I have 0 everywhere else. 70 is the answer. How about this one? Oh, 1 in the 128s. What else do I have? 1 in the 2s. 128 plus 2, that gives us 130. And let's take a look at this last one here. Oh, that looks tough. A lot of adding to do, isn't it? So we'd have to add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. What does that give us? 255. And there's actually an easy way to figure that out when we have all ones in this column. What would be the next value after 128, the next column? Well, that would be 256. So 256 would be 1 in the 256 column, and then all zeros. So if the next column is 256, and we have all ones here, we just subtract 1 from 256, and that's 255. That doesn't make sense. Don't worry about it. All you have to do, again, is add up wherever we have a 1 in that column. Add those column headings up, and we get the answer.
Yeah, sorry. Yeah. So as I'm saying that if there is a 0 in position, then do not add that value. If all 8 bits are suppose zeros, then the octet value is 0. If all 8 bits are ones, then the octet value is 255. I just observed in the video itself, right? So what we do now, let's have a small example, and then we'll go for one kind of exercise here. You can see. So what is happening? There is a octet bits. The octet bit values are written like 1, 2, 4, 8, 16, 32, 64, and this. Okay. So in our IP address, how many bits are there? Total 32 bits. These 32 bits are divided into octet 1, octet 2, octet 3, and octet 4. Means 4 8 bits are there. and their bit position starts from right to left, right to left, right? And if the binary address 32-bit IPv4 binary address is like this, suppose if it is given like this, then the human being what they needs to do, they needs to convert this binary value into a decimal value. Okay, so for that binary to decimal conversion of binary bit values, as you are finding, wherever there is a 1, that value is drawn. Okay, this 1 is multiplied by your 128, so value is 128. Similarly, 64 multiplied by 1, so 64. The remaining multiplied with all zeros, so the value is 0. So then what we need to do, we need to add these two numbers, 128 plus 64, it gives 192. So what is the decimal value of your octet 1 means 192. Similarly, for octet 2, the value is 168. Similarly, for octet 3, the value is 1, and octet 4, the value is 5. So, this is the way of conversion from binary to decimal of your IPv4 32-bit address. IPv4 32-bit address. Okay. So, now let us have a small exercise. Now, from this page, you just find out, okay, this is including a binary to decimal conversion activity that allow you to practice 8-bit binary to decimal, right? So here the 8 bits are given, these bits are given. Okay, convert these bits into decimal, and now tell me what is the value of these bits. What is the value of these bits? Just calculate and type in the chat box. What is the value of these bits? The binary IP address binary value should be converted into the decimal one, and find what is the value of this. Two 46. That's great. So let us have some more exercise. Let me just share the screen, other screen. Yeah. Now tell me what is the value of this number? What is the value of this binary number in decimal? 155. Is that correct? So let us see. That's true. So let's go with another number. Now tell me what is the value of this. Yeah. 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 So now find out for this value. 10101000. What it value? So you need to add 128 plus 32 plus 8. Then the value is 168. So now let us go with another number. Now see what is the value of this. 0001000. Is it 16? Just check it out. Correct. The next value. Try to calculate this. What is the value of this? This exercise is very important for further discussion. So that's why we are doing this activity. $142. Suchi 142. Devarsh 142. What about others? To calculate this, we need to add 128 plus 64 plus 32 plus 16 plus 2. Yeah, Parth, Ria, Asta. Good. Let us see what is the value. Now see, the value is 242. We need to add 128, 64, 32, 16, and 2. Since you are having binary bit values once, remaining locations is 0. So let us do one more number. Yeah. Now see what will be the value of this. The bits are bit stream of your one octet of your 32 bit is 11110110. Hemong is 246. Okay. What about others? Try to calculate. Good, 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 good. 246. Okay. Let us see what's the answer. It is 246. Absolutely. So now let's go with another number. Now see what is the value of this? All ones. All ones. You need to add 128 plus 64 plus 32 plus 16 plus 8 plus 4, 2, and 1. Exactly. Exactly. 255. We used to call this is as a broadcast address. Good, 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 good. Yeah. So let us go with another number and then we go to the next one, next topic. Now see what is the value of this. So these are only 8 bits. We are calculating we are converting binary into decimal of only 1 octet. Yeah. Users, it is 7. 4 plus 2 plus 1. 7. Good. 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 Okay. So last one. Let us see. Yeah. So what will be the value of this? $128 plus 64 plus 16 plus 8 plus 4 plus 1. 221. Okay, let us check. It is 221. That's right. So I think with this, I would like to stop the session here. In the next session, we talk about the IPv4 structure because these are very, very important for your networking purpose. So tomorrow in the next class, we talk about the IPv4 structure. So before that, let me ask you how many of you are given the feedback in the portal. Yours is EC2, right? EC2. Only 55 members have been given the feedback. I don't know what was the problem. you are given the feedback of a different kind of experience. I don't know. So how many of you are still needs to give the feedback? How many? If you are there, still we have 2 minutes time. You can just do it right now. So, I request all of you to enroll your number in the chat box. Enroll your number, please, in the chat box.
એટલે મારે એટેન્ડન્સ આવી છે મારે નેટ નથી ચાલુ એક આ પકડ એટેન્ડન્સ નાખવાની છે
Manthan Javia. Manthan Javia. You want to say? Okay, then those who completed, you just enroll your